All right, let's look at basically this is algebra, so consists of foiling, which is expanding the brackets. Let's see how you do here. So if you have x plus 7 times x plus 2, if you were to open the brackets, what do you get? Any ideas? Or better yet, let's do an easy one. Let's do an easier one. What if you have x times x plus 2? What do you get?
2x plus
So it's not going to be 2x. You first do x times x, which is what?
oh,
What's x times x? X times x. It's not 2x. X times x is x squared.
okay.
Okay, x times x is, there's a difference, right? Like look at this, 3 times 3. Well, for this one, 3 times 3 is not 6, it's 9, because you got to do 3 squared. So likewise, x times x is x squared, and then you have x times 2, which is 2x. Okay?
Okay.
Kind of works like this. Like if you have x squared times x, what do you think this is equals to?
Would it be cubed?
Yes, it would be. So the power just goes up by 1, or you just add the powers up. So if you have x squared times x squared, what do you get?
You just add a 4.
Yeah, exactly, x to the power of 4. Using this idea, we need to open this bracket, and in order to open this, you do this. You first do x times x, and then you do x times 2. So what is x times x?
X to the power of 2.
Yes, and then you have x times 2. What does that give?
2x.
Right, so you do plus 2x like that. But you're not done yet, because there's 2 terms in here, okay? There's 2 terms in here. Then you gotta do 7 times x and 7 times 2. What is 7 times x?
7x.
Yes, so plus 7x, and then you gotta do 7 times 2 plus 14, like that. Are there any like terms in here?
The 2x and 7x.
All right, so you have, if you add them up, what do you get?
9x.
Yeah, and that's gonna be the final answer, x squared plus 9x plus 14, okay?
Okay.
And this is called expanding the brackets or simplifying it. Let's do another one. What about the very next one? X minus 3 times x plus 3. So again, you first do this, right? X times x, you do this, and then you go this way. So what does this give?
X to the power of 2 minus 3x.
Yes, and then? There's 2 more terms.
Do you add or do you subtract?
So you look at the sign. So you see you're going to multiply minus 3 times x. Actually, this should have been plus 3x, because we did x times x plus x times 3. Okay.
Oh, okay.
And then we're going to do minus 3 times x. What does that give? Minus 3 times x is minus 3x. And then you do minus 3 times 3. What is that? Minus 3 times 3.
Minus 3x.
No, minus 3 times 3. So minus 3x comes from minus 3 times x, this arrow.
Oh.
Okay, we've dealt with this. And then finally you do minus 3 times 3, which is
minus 9.
yeah, minus 9. There you go. All Are there any like terms here?
The 3x,
So what's plus 3x minus 3x?
just x.
No, plus 3x minus 3x is a 0. They cancel each other out. 3x
okay.
minus 3x is a 0. So you're just left with x squared minus 9.
Okay.
What about this one? X minus 5, and now there's a whole squared element to this.
X to the power of 2 minus 25.
Not as easy as that, right? No, by the way, that's not gonna be the case, because that's a very it's a good answer, but it's not the right answer, because if you're to expand this, look at this, you gotta do it this way, okay? It's a very common mistake. X minus 5 squared is not x squared minus 25. Well, these are going to be parts of it, but you'll see here, there's a missing term in the middle. If you do it the long way, right? X times x is x squared. Then x times 5 is what? Or x times minus 5 is minus 5x, yeah?
Mhm.
And then you have minus 5 times x. What is that?
Minus 5x.
Right, minus 5x. And then you have minus 5 times minus 5.
25.
Yeah.
Plus 25.
Plus 25. So this gives you x squared minus 10x plus 25. You see?
Mm-hmm.
If you group up the like terms, so it's not x squared minus 25 because there is a missing term in the middle, which is 10x.
Okay.
But if you have now, when is it gonna be x squared minus 25? It's gonna be x squared minus 25. If it's like this, x minus 5 times x plus 5. Like in this case, that is gonna be x squared minus 25, but not
Okay.
x minus 5 whole squared. There's a missing minus 10x term in the middle. That's why. Let's do a couple of these and we can move on from this. Can you ignore that f? All right, here. Again, do it like this: 3x times this, and then this way, and then you go this way. What's the first term?
3x to the power of 2.
Yes. And then?
Minus.
Minus what?
Wait, what do you do for the next one?
Okay, so we did 3x times x, right? The first thing. Look at the arrow. We did 3x times x, this arrow. This
Mm-hmm.
is done. And then we got to look at the next arrow. We do 3x times negative 5. (3x times negative 5).
Negative 15x.
You're right, exactly. And now we've dealt with the arrows on the top. Now we look at the bottom. We do plus 1 times x, which is a plus x, yeah?
Mm-hmm.
And then we do plus 1 times negative 5, which is minus 5, like that.
Okay.
If you group up the like terms, what do you get?
14x.
Yeah, positive or negative?
Negative.
Yeah, so minus 14x. There you go, we're done with this. Let's look at the next one. 2x plus 3 whole squared. Again, this is gonna have 3 different terms, not just 2 terms. So I'm just gonna write it like this. Whole squared means it's multiplying. Whatever's in the bracket, it's multiplying itself. And we gotta follow the arrows, okay? It's gonna look something like this, and then we go this way. So what's the first term?
Is it 4x?
Just 4x? It is. There's a 4, there's an x. So when you're doing 2x times 2x, you want to multiply the numbers together and the letters together. 2 times 2 is 4. What's x times x?
To the power of 2.
Yeah, exactly. So 2x times 2x is 4x squared. Okay. What's the next term here after 4x squared?
Plus 6x.
Yes. What's the next term after that?
Is it just plus 6x again?
Yes, it is. What was the final term?
Plus 9.
Yes, there we go. And if you group up the like terms, you get 4x squared plus 12x plus 9. And there you go. That's the final answer.
Okay.
Yeah, the rest is kind of the same. All right. Let me introduce you to an idea that you've kind of you haven't seen yet. It's gonna be something new, but it's gonna be fun. Anything new is fun. But not fun, but maybe it's interesting. That's what I mean. So you know this is a linear line, like a linear function. Y equals 2x plus whatever that is, plus 1. Now, if I were to ask you, this is called linear for a reason. Do you know why this is called linear?
No.
It's because what's the power of x?
1.
1, exactly. 1 means linear, okay? Now, if you dial it up a notch, right? What if we go to the next level? What if we do something like this? Y is equals to x, but now it's no longer to the power of 1. If it's to the power of 1, you don't even have to write it, right? But what if we take it up a notch? We write it to the power of 2. Is this linear?
No.
No, it is not no longer a linear because there is a power of 2, right? Now, what could that possibly look like graphically on this graph? We can graph it. I mean, we can even graph y is equals to x to the power of 100. We can graph anything, but let's not worry about that. Let's just go to the next step here. X squared. Any ideas what that could possibly look like? What do you think it's going to look like? Is it going to have 2 different lines or? There's no wrong answer here. Like, what do you think it looks like?
I don't really know.
So it's going to look something like this. Okay, and you're going to have to bear with me. It looks pretty nice, actually. It looks like this. It looks like a U. There you go, like that. And this is y equals x squared.
How does it look like that?
All right, so let's see why it looks like what it looks like. Let's make a table of values. Okay, x and y, and we are going to plug some points in. Again, this is y equals x squared. If x is 0, what's the y value? For this, plug x as 0.
1.
No, 0 squared, right?
Oh,
What's 0 squared?
it's just 0.
It's just 0, exactly. There we go. We have our first point. If x is 1, what's the y value?
1.
1. If x is 2, what's the y value?
2.
No. 2 squared.
Oh, 4.
4. If x is minus 1, what's the y value?
Minus 1.
No, minus 1 squared, right? Minus 1 squared, which is minus 1 times minus 1, positive 1.
Oh, okay.
If x is minus 2, what's the y value?
+4.
Yes, good. There you go. Now let's graph that. So we have 0, 0, which is right here. 1, 1,
Mhm.
2, 4. So that's a 4 there. 2, 4 is up there. And then on the other side, we have -1, 1, and then 2, 4. You see, if you join the dots, we're gonna get something like a U. And then we can keep going. 3 is gonna be 9. If you wanted to, 3 is gonna be 9. -3, funnily enough, is also gonna be 9. There you go. And you can keep going till infinite, like infinity. 4 is gonna be 16, but there's not enough space here. 4 will be somewhere up there, -4 will be somewhere up there.
Oh, okay.
Okay, so this is what? This is y equals x squared.
Okay.
Now you might wonder, well, why is this not linear? Well, it's not linear because there's a power of 2, but theoretically, linear means for every x value, you have one y value. Okay, 1, 1, 2, 2, 3, 3, whatever. For every x value, you have one y value. But if you look at a quadratic or x squared, right? X squared, look at this.
Mhm.
For every there's 2 different x values for every one y value, right? There's 2
Mhm.
different y values for every, or for 2 different x values, there's one y value. So -1 to 1 both gives you 1, right?
Mhm.
So it's a 2 to 1 ratio. That's why linear means it's a 1 to 1 ratio. For every one value, there's 1, but for this one, y equals to x squared, there's 2 different. The name for this one is, it's called a quadratic. It's a quadratic function. X power 2, like x power 1 is called a linear function. X power 2 is called a quadratic function. And this U shape, you see this arc, this is called a parabola.
Okay.
Hey, good so far? It's something
Mhm.
new, right? It's interesting. If anything new, I mean, it's not that difficult, but it's something new. There you go. That's what it looks like. Again, this is, we're not going to do this next step, but if I were to ask you, what could y equals x to the power of 3 possibly look like?
A U.
No, that's x power 2, right?
Oh.
Now, if I were to ask you x power 3, what could that possibly look like? And we're not going to do this for a very long time. Don't worry about this. We'll probably, this is like, yeah, this is beyond our scope, but what could that possibly look like? Power 1 looked like a line, right? Power 2 looks like a U. Let me tell you,
Would
it's not
it
going to be straight. It's not going to look like a straight line, that's for sure.
would it go around or something?
Kind of. So it looks something like this, which is pretty interesting. It looks like an S. It looks like this, like a snake, like that, and then it's gonna go up. And you can always find this by plugging in a table of values. X power 3
Okay.
looks like this. So U, instead of U, the left half of the U goes down.
Oh, okay.
Okay. Y equals to x4. Now, what could that look like? Now, from here, the pattern repeats. Only 1, 2, 3 are going to be unique. From anything above 3, the pattern is going to repeat. X power 4 looks the exact same thing as x power 2, except it's going to be a little bit fatter. So this blue one here is x power 4. And then from here, the pattern is just going to repeat, like x power 5 is the exact same thing as x power 3, except it's going to be a little bit fatter around the origin. You see this?
Mhm.
Like this, x power 100, is that an even number or an odd number? The power.
Even.
Even, right? So what could that look like? It's going to look the exact same thing as x power 2. it's gonna look something like this. It's gonna be very fat though, like around the origin. It's gonna look like a vase, basically, like a bucket. But it's not gonna be straight. This is straight because of the limitations of the graph, but it's not gonna be straight. Here, let me show you. So this is x power 2, yeah, u.
Mm-hmm.
X power 3 looks like an S through the origin. And from here, the pattern repeats, right? X power 4 is going to be the same thing as x power 2. But it's going to be fatter around the origin, you see? The green one,
Mm-hmm.
it's going to be fatter. Then using this logic, if you were to do x power 100, it's going to be very fat here. So it's going to be so fat that it's going to appear to be like a box, but it's not a box. Like there's no straight lines here. These are just curves. You have to zoom in to see that. From the outside, it looks like a box, right? You can even add an extra 0 here. I don't know if this can handle it. Yes, it can. Look at that. That looks like a straight line, right? But it's actually not straight. There's no straight lines here. If you zoom in deep enough, anyways, you'll see that they're all curved. From the outside, it looks like a straight line, like a rectangle, but it's not. But for our purposes, we will not go beyond x power 2, okay?
Okay.
We will not go beyond x power 2. This one, it's just asking you to simplify this, to open the bracket and to group up the like terms. So we have x plus 2 squared, right? Whole squared. So we're going to rewrite this as x plus 2 times x plus 2 plus 3. Now we're going to open the brackets. To do that, you first do this, and then you do the second term there. What do we get?
X to the power of 2 plus 2x.
Yeah, and then?
Plus 2x.
Yes.
And plus 4.
Plus 4, exactly. And then we have a plus 3 on the outside, yeah? So we get x squared plus 4x plus 7. This is also a quadratic function, x power 2, but instead of it looking like this, right? I mean, it's going to look like that, but it may not be exactly at the origin. This one is going to be a little bit here, a little bit higher. Because there's a plus 7. You see the y-intercept? Like a linear function, this is y equals to x, or 1x plus 0, or y equals to x. That's a parent function. But if you were to introduce some like y equals 2x minus 3 or something, it's going to go up or down and switch a little bit, right? Same idea with this. The shape stays the same, but it's going to move up and down a little bit depending on what's going on. Overall, it is a u, but it's not going to start at the origin. This one especially is not going to start at the origin. It's a let's try doing another one. The goal is to simply open the brackets and group up the like terms. How do we do this?
Do you what happens to the 2 on the outside?
It's going to stay on the outside. So we're going to do 2x. Don't throw this in yet, because you see this is power of 2. This doesn't have a power. So it's just going to stay on the outside. And now we're going to go this way. Eventually the 2 will come in once we've opened the brackets. So 2 is still on the outside. What do we get on the inside?
X to the power of 2.
All right, x to the power of 2. And what's the next term?
Minus 1x.
Yeah.
Or
yeah, that's right. Our x times minus 1 is minus 1x, and
minus 1x.
Yeah.
plus 1.
Plus 1, exactly. So if you group up the like terms on the inside, right, we will get x squared minus 2x plus 1. All right.
Mhm.
Now we finally throw the 2 in as well. So by throwing the 2 in, I mean you got to do this. Multiply everything inside the bracket by the 2 that's on the outside.
2x to the power of 2.
Yes. What else?
Minus 4x.
Yeah. And
Plus 2.
right. And there you go, you're done. Final answer there.
Mhm.
So this one it's asking us, are these two equal? Is the one on the top the same thing as the one on the bottom? How could we possibly check that?
Like by opening the brackets.
Right. So again, we're gonna deal with the guy that's on the top. Minus x plus 1 squared plus 3. Leave the minus on the outside for now, which is the same thing as minus 1. We're gonna clean up the bracket bit, the inside, and then we're gonna throw the minus 1 inside. So again, the minus is on the outside for now. We are going to open up the brackets, which works like this. What do we got here?
X to the power of 2.
Yeah.
Plus x.
Yes.
And
Then you follow the arrows on the bottom. So you do plus 1 times x.
so plus x.
Yes. And then finally you do plus 1 times plus 1, which is a 1. Like that. And then
Do you add the negative?
Yeah. Yeah, you could throw it in. Plus x is 2x, right?
Mhm.
So I'm just gonna write this as 2x to save some space. And then finally you want to throw the negative on the inside. So you get minus x squared minus 2x. What's the last term here?
Minus 1.
Minus 1 plus 3. And then you want to group up the like terms. What's minus 1 plus 3?
2.
Yeah, plus 2. So is this the same thing as the one on the bottom?
No.
No, so they are not equal. This one looks like this. The y-intercept is 2, right?
Mhm.
Whereas this one, actually, it's not gonna look like that. Because now look at this, like how if the slope is negative, the graph instead of going this way, it goes this way, right? For
Mhm.
linear functions. Same idea here. If this guy is negative, the number that's attached to x squared, what happens is instead of opening like a U, it's gonna be an inverted U, like an upside down U. So this is probably gonna look something like this. It's an upside down U.
Oh.
It flips upside down. And this one is gonna look something like this. It goes through minus 4. It goes through, it's gonna look like that. Yeah, they're not the same, we knew that, but graphically that's what it looks like.
Mhm.
What about this one? Are they the same?
And we have to open the brackets.
Right, so you got 3 x minus 2 times x minus 2 minus 4. Again, leave the 3 on the outside for now. You're gonna go this way, x times x and this way. So what do we get?
X to the power of 2.
Yeah.
Minus 2x.
Yeah. There's 2 more terms.
And then minus 2x
Yes.
plus 2.
So what's minus 2 times minus 2? It's not plus 2.
Oh, plus 4.
Yes. And then we have minus 4 on the outside.
Mm-hmm.
Yeah. So if you group up the like terms, you would get x squared minus 4x on the inside the brackets, and then you want to multiply everything on the inside with the 3 that's on the outside. So get 3x squared minus 12x plus 12 minus 4. And then finally, 12 minus 4 is an 8. So you get 3x squared minus 12x plus 8. Are they the same thing?
Yes.
Yes. And you're done. Okay.
Mm-hmm.
All right. Now there's going to be something new here as well. Some new ideas. If you look at this graph, right? You know what a vertex is for a triangle? These are called vertexes. It's called vertices in plural, but individually they're all vertex. Basically, the pointiest end of the diagram or the polygon, whatever. You see, these are the vertexes. A linear function doesn't have any vertex. It's pretty smooth all the way around, right?
Mm-hmm.
Doesn't have a pointy end. But a quadratic, by quadratic I mean x power 2 function, it does have a vertex. Where's the pointiest end? What's the coordinate of this point right here? What is that point as a
1 and negative 4.
There you go. So that's the vertex, 1 and negative 4. Now this part is going to be pretty difficult. Write the equation in vertex form. We know this is a quadratic. It's x power 2, okay?
Mm-hmm.
Like, you know, for linear functions, we had this general form, y equals mx plus b, where m is the slope, b is the y-intercept. There's a general form for a quadratic as well, and it looks something like this. Y equals a x minus h squared plus k, where h comma k is the vertex.
Okay.
Now, if we were to plug h comma k in this equation, we would get, again, we don't know what the a value is yet, so that's okay. Let's plug the h value in. We know h is 1, so we get x minus 1 squared.
Mm-hmm.
And we know the k value is minus 4, like that. Okay?
Okay.
This is the general form of a quadratic. Eventually you're gonna remember it, but I'm gonna give it to you every single time for now. Now the question is, how do we find a? Now, if you remember for linear functions, how did we find the b value? Like, for example, if we had something like this, how did we find the b value? If they gave us a point.
You would just plug it in.
Yeah, you'd plug it in and solve for b. Same idea here. If you look at the graph, we can use any point they've given us. What would be an easy point? Probably this one. That is 3, 0. Okay.
Mm-hmm.
So we're going to plug that as x and y to solve for what a is. So we know the y value is 0, and we know the x value is 3. There we go. Now we get an equation. It's not a linear equation, but the same. Actually, it is. How do you solve this equation for a?
You add 4 on both sides.
Right. So you get 4 is equals to 8 times 3 minus 1 squared, which is just 8 times 2 squared. Now what?
you find the square root of 4, which is 2.
No, you don't have to do that. So 4 on the left stays as it is. What's 2 times 2?
4.
4, there we go. You're only gonna square root both sides if the variable has a power of 2, like something like this. Then you would have square root both sides.
Oh, okay.
And if we get 4 equals 8 times 4, we can divide both sides by 1. We get a equals 1.
Mm-hmm.
So therefore, our thingamajig is going to be, when a is 1 on the outside, you can ignore it. We have x minus 1 squared minus 4.
Okay.
Now part B is asking us to check whether this thing is equals to this thing to see if we've done it right. So let's open up the brackets. We have x minus 1 times x minus 1 minus 4. If we open this bracket, what do we get?
X to the power of 2
Right. And
minus x.
yeah,
And then minus x again.
yeah,
Plus 1.
yes. And then we have plus 1 minus 4. Now, if you group up the like terms, we get x squared minus 2x. This is x squared. Okay, x to the power of 2 is called x squared. Eventually, you might see this. This is called x cubed. 3 is cubed,
Mhm.
2 is squared. What's plus 1 minus 4?
-3.
Yes, and there you go. See, this is the same thing as this. That means we've done it right.
Okay.
That makes sense?
Mm-hmm.
Now here's a word problem. There's always going to be word problems in any topic in maths. Step 1, if you look at the equation they've given us, the y value h, it represents the height, and the x value t represents the time in seconds. Let's compare that with this. So we have minus 5 t minus 0.6 squared plus 11.8. Yeah. Let's compare this with a, x minus h squared plus k. And why are we doing this? Because we need h comma k. The vertex tells us everything. If you compare these two together, what's h comma k? Now, what's the h value?
0.6.
Yeah, h is 0.6. And what's the k value?
11.8.
Right, 11.8. Now, what does that mean? What do you think that means in the context of this question? The graph looks like this. And I don't know where the x-intercepts are, but like this. And this point right here, this point is our vertex, okay? H comma k is always the vertex. That is 0.6 comma 11.8.
Mm-hmm.
On the y-axis, we have height in meters. On the x-axis, we have time in seconds. So what does that point represent? Well, that point represents a vertex, right?
Mm-hmm.
Now, what's the vertex in this question? It's the maximum height.
Okay.
So after 0.6 seconds, the diver reaches a maximum height of 11.8. So sometimes he's jumping off of here, right? And then at this point, he is 11.8 meters high. And the time is at 0.6 seconds after he's jumped off the board.
Okay.
All right, you understand that? So
Yeah.
the max height is 11.8 meters. And we can just find this by comparing this with our quadratic formula there, the general form. Part B, how long after the diver left the platform does she reach her maximum height? I mean, we already have the answer to this. What is that?
0.6.
Yeah, exactly, 0.6 seconds. C, what is the y-intercept and what does it represent? Now, y-intercept represents the same thing as it would do in the linear function. It's the initial height, or when time is 0, yeah?
Mm-hmm.
So that's the height that she was in before she jumped. So maybe the board is here, right? Maybe the ground is here. Y-intercept is how high this is, the initial height of the diver.
Uh-huh.
How do we find this in this case? To find the y-intercept, you're gonna have to open the brackets and find
Okay.
out what the number by itself is. This is not the y-intercept. Again, the rules are kind of the same. We need to find the b value in this case, like we would for linear. But
Mhm.
you see that 11.8, that's not the y-intercept. We need to open this bracket up and see what the actual number is. The 11.8 is the maximum height. So to open the brackets, we're going to rewrite this as -5 t minus 0.6 t minus 0.6 plus 11.8. Okay, we're just opening the brackets to see what the actual b value is, and that is going to be the initial height of the diver.
So t to the power of 2.
Right, so you have t squared minus 0.6t minus 0.6t plus 0.36, which is 0.6 times 0.6 plus 11.8. If you group up the like terms, you get minus 5t squared minus 1.2t plus 0.36 plus 11.8. Now you want to open the brackets, you get minus 5t squared plus 6t. And what is plus 0.36 minus -5? 0.36 times -5. That is minus 1.8 plus 11.8, like that. And then finally, we just want to group up these numbers. So we get 10 minus 5t squared plus 6t plus 10. And you see this number here is our b value, the y-intercept.
Okay.
So that's the initial height of the diver. Okay, so this person jumps from 10 meters, reaches a maximum height of 11.8 meters after 0.6 seconds. There you go. That's the whole question.
Mm-hmm.
That makes sense to you?
Uh-huh.
So the only complicated part here is this part because it's new. But again, you're just comparing the numbers. It's not that bad. Just compare one with the other. It'll give you the vertex. Once you have the vertex, you can answer any question they throw at you for these. All right, so let's move on to something else. So now we're gonna common factor things. So before we were opening the brackets, but now we're gonna introduce brackets. You're gonna pull out the GCF of the entire thing. Here, let me do one for you. What am I talking about? So 6x plus 8. What's the greatest common factor between 6x and 8?
Could you just multiply the 2?
So now we're pulling some things out, okay? So the GCF, again, you remember what GCF is? Greatest common factor. This
Mhm.
is the biggest number that you can pull out between 6x and 8. In this case, it's going to be a 2. Right? If you want to go do the old school way, 6 is 2 times 3, and 8 is 2 times 4, and then one more level, 2 times 2. So 6 is 2 times 3, 8 is 2 times 2 times 2, right?
Uh-huh.
What they both have in common, you see this one, that's the GCF.
Okay.
Is equals to 2. Do you remember how to find the LCD? The lowest common denominator, or the lowest common multiple? That is going to be what they both have in common, 2, right? And
Mhm.
everything else. Like that. It's 24.
Oh.
Okay, but we
Okay.
don't care about the LCD here. We're strictly concerned with GCF. You don't even have to do this, but it's just logic. Like, what's the biggest number that can go into 6 and 8? It's going to be a 2. All right.
Mhm.
So we're going to pull the 2 out. And if I pull it out, what am I left with in the bracket? 2 times what is 6x?
12x.
No. 2 times something is 6x. 2 times 3x is 6x, you see? Now we're
Mhm.
working backwards. Instead of multiplying, we divide. 6x over 2 is 3x. 2 times something is 8.
4.
4, there we go. And now we've factored it. Okay, we're doing
Mhm.
the opposite of what we were doing last time around. Let's look at the next one.
Okay.
Between 6x and minus 2, what do they both have in common?
2.
Exactly. What am I left with in the bracket if I pull out a 2?
3x minus 1.
Yeah, there you go. Easy as that. Next one. What do 5 and 10 have in common?
5.
Yes. What am I left with in the bracket?
X plus 2.
Right, x plus 2. Negative 3 and 9. What do they both have in common?
3.
Yes, but in this case, it's going to be minus 3. And you're left with an x on the inside. And what's 9 over minus 3? No, minus 3 on the inside, because we took out a minus 3.
Oh, okay.
So 9 over negative 3 is negative 3 on the inside. Okay.
Mhm.
Let's try doing another set. So again, you want to take out the minus sign if there is one, because you don't have a minus sign if possible inside the brackets. So between negative 15 and negative 25, what's the GCF? What can we pull out? The biggest
5.
number, yeah, minus 5. Pull out a minus 5, what are we left with in the bracket?
3x minus 5.
Right. But again, be careful, okay? 3x plus 5. Because negative 15x over negative 5 is positive 3x, and negative
Mhm.
25 over negative 5 is a positive 5.
Oh, okay.
Next one, between 2x and squared and minus 4. What do they both have in common?
2.
Yes. What are we left with in the bracket?
Um,
So again, just do 2x squared over 2. See the 2's cancel out?
mhm.
You're left with an x squared. And then you want to do minus 4 over 2. What is that?
2.
Minus 2.
Mhm.
Does that make sense?
Uh-huh.
Okay, now this one, there's going to be 2 different things that we can pull out, not just a 2. You're going to pull out a 2. What else can you pull out? Something they both have in common.
3.
No, 3 doesn't go into 2, right? I was talking about a variable. You can pull out a variable here. You see x plus, or x squared plus x, you can pull out an x, because x goes into both of them.
Oh.
X times what is x squared?
X.
Yes. X times what is 1? X. 1.
0. Oh.
No, x times 0 would be a 0, right?
Mhm.
A 1. So there you go. So we can pull out an x here, and we are left with 2x times what is 2x squared? 2, sorry, an x. 2x times what is 6x?
3x.
Oh, just 3, just 3.
Okay.
Because 2x times 3x would be 6x squared, and that's not what we have, just a 3 there. The next
Mhm.
one, what can we pull out?
Um, 2x
We can't pull out a 2,
or
because 2 doesn't go into 3.
So just x.
Just an x. What are we left with in the bracket?
2x.
Minus 2x now, right? X times what is minus x squared? Minus 2x, and
Do you add 3 or minus 3?
so you want to do negative 3x over x.
So minus 3?
Yeah. Okay, like that.
Okay.
What about here? What can we pull out?
3?
So you can pull out something else other than 3. What do x squared and x have in common?
X.
X, exactly. So what are we left with in the bracket?
X
Yep. And
plus 9.
yes, there we go. And you're done.
Okay.
Easy? Easy enough, right? What about this?
X
Yeah. And what are we left with?
minus x
You're good. What else?
plus x.
No. Try again. With a plus x there, we would have had
1.
yeah, 1, right? Not a plus x. That would have given us 1x squared, which is not the case here. What if I throw you a curveball? What do I mean by that? That I mean something like this. The question is to factor this, okay? But notice they have nothing in common. What's the GCD here? Or GCF, sorry. What can we pull out? We can't pull out anything. I guess we could pull out a 1, but that's not going to change anything. The GCF between both of these is a 1, okay?
Okay.
But that doesn't help us because we can't really do much with it. How do we approach a question like this? Because not always are they going to have some things in common, okay? But that does not mean you can't factor them. For this one, we are going to introduce a new idea. And this is called a difference of squares. Now, what does that even mean? It means this. If you have something in this form, a squared minus b squared, you can factor it as a minus b times a plus b. Quick examples. If you have x squared minus 25, yeah, I'm going to rewrite this as x whole squared and minus 5 whole squared, like that. And then we're going to compare this with a squared minus b squared. What is a and what is b? A is x.
X.
What is b?
5.
5. There we go. So that means we can factor this as a minus b. So x minus 5 times x plus 5. A minus b, a plus b.
Okay.
So this one first, we're going to have to rewrite this as x whole squared and minus something whole squared. What goes in this bracket?
3.
3, exactly. What's the next step? It's a minus b, a plus b. We know a is x, right?
Mm-hmm.
So x minus 3, a minus b times x plus 3, like that.
Oh, okay.
Okay. So see, even if they had nothing in common, we can still factor them.
Mm-hmm.
Cool, that makes sense.
Yep.
All right, we'll pick it up tomorrow from here.
Okay. Thank you.
Bye-bye.